Hi guys, good morning. I hope you're able to hear me. Can anyone please confirm? Okay. So very good morning everyone. Okay, so in the last session we have seen how we can get the word count and how we can add a value for each and every the line wise how we can add it that we come across it. And I guess we have seen how we can like the partitions we started talking about it. I think. In a moment, I will tell you. In between that, I have done something. Before that, let me create a complete first. I'll come back to here. Yeah. So now it is done. So in the last session, we just started talking about this, how we can increase or decrease the number of partitions if you have such kind of requirement, how we can do it. That we have just started and we kept it. So yesterday, I have written this catch, but that is not a catch, guys. That is a policy. So policy and repartition, we can use these two options in order to increase the number of partitions. So we have seen the first option here. While reading data from the file, we can increase or decrease the number of partitions. Even we can use this parallel function also. On that particular place also, we can increase number of partitions. So that's going to be possible. And if I wanted to do with these two options, the rest of the two options we have it, right? We can also use those two options in order to increase or decrease the number of partitions. Okay, so we have the data here. Okay, so increasing number of partitions up to 5 while reading the data from the file with the sa.txt file, we can increase the number of partitions. So which partition is having this data we have seen in the last session. Okay, let me re-execute this again. This is the output of this. Okay, so sorry, this we need to take it out. Okay, let me take out this. Basically, you have to show up to here only. Okay, so whatever I got, that I just keep it here for just visibility, because this is having in one partition, two partition, third, fourth, and five. So total 5 partitions. Now I wanted to increase the number of partitions. Okay, I wanted to increase the number of partitions. Okay, so let me take this function. First, what is this function? You need to understand. Colossi. Added dot Colossi. It is used to reduce the number of partitions. Okay, so we have a two options are there in order to reduce or increase. Okay, so when you go for increase the number of partitions, while reading, you can increase it. Okay, while reading, you can just give some. Okay, that may be increase or decrease. But this coalescing function is going to help you to reduce the number of partitions. It will not help us to increase the number of partitions. So if you want to go for increase, then you have to use the repartition. So repartition will help you to do increase as well as decrease. Both you can do with the help of repartition. Whereas with coalescing function, it is going to help us to only reduce the number of partitions. Okay, so RDD.coalescing, it is used to reduce the number of partitions. We are already having 5 partitions right here. In this particular RDD, we have the 5 partitions. So I'm just going to reduce the number of partitions. We can say create RDD with 5 partitions and then reduce partitions to 3. So we already created, again I'm just taking it. Okay, let me take this here. Now it is there with 5 partitions. Okay, so when I use this, this is the value that we are having, right? Even here you can see for reference. Now I'm going to reduce the number of partitions with coalescing function. So in order to reduce the number of in order to reduce number of partitions, you can use the coalescing function. Let's say data dot coalescing. I wanted to reduce up to 3. Reduces number of partitions up to 3. Now I wanted to say get num partitions on top of this. Okay, so the result I just wanted to keep in another RDD. Let's say RDD 1 equals to RDD 1 dot get num partitions. Let's execute it. Now you can see 3 partitions are there because we reduced up to 3 partitions. Now if you want to say what is there inside this RDD1, I mean to say what data is there in each partition, then you can use RDD1 dot glue dot collect. You can see. So I'm just taking a copy and paste it here. You can see this is one partition and this is one partition and this is one partition. Okay, I'm just keeping something like this for better understanding. And here also I'm just going to keep something like this. Now just compare this value. For comparison, I'm taking so the first one is there as it is, the same partition. But if you see the second partition, this value and this value. Okay, so these two are combined. Okay, and here also the same thing. Okay, so these two partitions are combined. Okay, so because we reduce the number of partitions. So when you reduce the number of partitions, if there is a side-by-side partitions if you have, it is just going to combine as a one partition. Okay, so we have something like this: partition 1, partition 2, partition 3, 4, and 5. Okay, so partition 1 is having as this partition 1. Okay, it is converted, and this partition 2 and partition 3, they combined and they name it as partition 2. Okay, because we converted as we reduced the number of partitions, right? And this is P4 and P5 combined as P3. That is what we are saying. The P4 and P5 is coming as a P3. Okay, so we can reduce the number of partitions. Okay, so that is about this coalescing function. Coalescing function is going to help us to reduce the number of partitions. Before reducing number of partitions. After reducing number of partitions. Okay. And another function we have, that is I'm just taking the same thing. Repartition. So repartition, it is used to reduce or increase number of partitions. So if you want to increase the number of partitions, that is possible to increase the number of partitions. I'm just going to say create a DD with 2 partitions and then increase number of partitions to 5. Okay, so that I'm just going to say here 2. Let me take out this. I'll copy and paste again. So here I'm going to use not repartition. Let me comment this or take out. So I'm just going to make this as a 2 partitions only. If you run this, it is going to have all the data in a 2 partitions. rd1.collect. It is coming as a 3 partitions. Okay, not rd1. It's a bit data. Now there is a output here. Let me take this. So before increasing number of partitions, I'm just going to say, okay, so this is 1 partition. And this is second partition because we kept only 2 partitions. Okay. So while reading the data, I just keep only 2 partitions, this entire data. I wanted to increase the number of partitions. So if you want to increase or decrease, for both of them, we can use this repartition. And this is going to reshuffle also. The data is going to reshuffle. Okay, so let's see how exactly it is going to be happen, what we are going to get after increasing number of partitions. I wanted to say already 1 equals to data dot repartitions. I wanted to go with up to 5 partitions here. Now I wanted to see what is there inside this already 1 after increasing number of partitions. Before increasing, after increasing. Let's execute it. And see how it is there. What is this 2 partitions only? Or something went wrong. Repartitions up to 5 rd1.glow. Let me check the number of partitions. What is this? Okay, let me cut this. Okay, perfect. Okay, so I'll keep this copy and paste again once this is executed. Because of the text, it is not allowing to take it. Now you can see. This entire data is there in a single partition. Whatever the data we are having here, all this data in a single partition. Again, it is having partition 1, 2, 3, 4. 4 partitions are empty partitions. So total number of partitions are created. I mean to say 5 partitions we're expecting, 5 partitions are created, and so it just kept the data in a single partition, whatever the data we're having in 2 partitions previously. After increasing the number of partitions, we're getting the data like this. So this is my intention here is how we can increase the number of partitions or how we can decrease the number of partitions. And if you want to decrease the number of partitions, again, you can use the same. In the next cell, I'm just going to take it for just reference. You can go with 3 partitions. Already 1.3 partitions. Let's say 2. Already 2 dot bloom dot collect. Let's execute it. You can see this is one partition and this is another partition and there is a one empty partition. So we can reduce it by using repartition. We can increase or we can decrease the number of partitions. Okay, and the next is till now what we have done is we have seen like how we can decrease the number of partitions or increase the number of partitions. If you have a structured data, like in a text file, if you have a data, then how exactly you're going to handle it. Okay, so let me check that file available or not. File store AD02 source. Okay, so I'm just going to take the file called employee.txt file into here. Let me upload it. Upload here. Where is this employee.txt? Yeah. So employee.txt file I'm taking. Let's say done. Now I wanted to see the data first. How exactly the data is there here. Okay, now my question is how we can validate it. I'll do one thing. Okay, I'm just saving this file because I need to show how we can validate also. Okay, that is fine. Now again, I'm just going to upload that file. So to upload it, first I have to remove it. DB util start fs.rm / employee.txt. Now no file is available. Let me re-upload it again. Where is this? Yeah. So I wanted to read the data from here. In order to read it, we can go and write it. RDD, right? So my task is create RDD by reading data from employee.txt file. Okay, so I'll save the file and you can also use the same employee data into that particular place, so that will be better option to validate the data. You can cross verify with SQL. Okay, and that is one thing. And the second one is I wanted to take the data from RDD, like I wanted to take specific columns. Before that, we are going to get a header. Take out header from the RDD. Third is display data for all the columns. Okay, simple. I just wanted to say select star from table name. This is the equivalent thing that it is going to show here. Okay, so select star from table name. I'm just giving an example here. Select star from table name is employee. So how exactly you can do it here, that I'm just going to take you through. The first step is you have to read it. So I'm just going to say RDD1 equals to sc.txt file. And you can pass this path of the file, file store, AD02 stores employee.txt. So if you want to say what is there inside this RDD1, RDD1.collect. Okay, here it is comment. Let me re-execute again. Now you can see how data is there. So once you have this data, what you have to do is we need to split this data. The next step what you have to do is, let's say RDD2 equals to RDD1 dot map lambda x colon x dot split. So split is based on comma. Now I wanted to say what is there inside this RDD2. So list inside a list it is going to give. List inside a list is going to give. So we are having list inside a list. But the first list is not required. This is having a header. I don't need the header. I need only data. So basically, your RDD is not going to have the header. Okay, so we have to take out this first item. So if we can take out this, then we can have the data except this header. So in order to do this, we are going to use a filter function. With map, we already done, right? We already talked about it, map, how we can use this map, and even filter also we talked about it. Filter will be used to restrict the data based on the condition. We have come across it. Now, on top of this, what I'm going to do is RDD3 equals to RDD2 dot filter. Then lambda x colon x dot we have to take a starts with what? This one. I'm just taking employee number. Starts with employee numbers. Then I wanted to see that data out. Let's execute it. List. Yeah. So we have to take, before that, let me comment this. Let's execute again. RD2.collect, I'm just taking. Okay, so this is going to give x of 0. Let me check. So here x of 0 I'm taking. X of 0 dot starts with, let's try this on this one. RD3 dot collect. Yeah. So because I'm just taking the first x of 0. Okay, x of 0 means first list is going to get. Okay, x of 0 starts with employee number. Then I wanted to take it only that particular list, that particular item. Okay, so if x of 0 starts with employee number, that value I wanted to take it. So basically I don't need this. If I don't need this, then we can say somewhere it is not. I'm just going to say not x of 0 starts with, let's try again. Yeah. Now this header, we are not having it. Okay, so if I take out this not, it is just going to show the only header. Okay, we already know about this starts with. So starts with is used to take the, it is used to check is the text is started with a specified text or not. Even in Data Factory also we come across the starts with function. Okay, so I'm just excluding that header. To exclude the header, we need to say not header. Then that detail only I need to take it. Okay, so this is how we can take the data for all the columns. Okay, so we are having the data for all the columns in this place. Okay. So the data is getting into multiple lines is because this is having a values here. In some places here, we don't have a values, it is fitting into single line. In some places it is fitting into single line. Let me re-execute it. So sometimes, I mean to say it is fitting sometimes in a single line and sometimes in a multiple line also. Okay, so this is how we can take the data from all the columns. So if you need a specific column, then you can take it to a specific columns. So what I wanted to do here is for all the columns itself, but your employee number, if you take, your employee number is an integer data type. I wanted to show this as an integer data type. To show this integer data type, this is also integer data type, and this is a float data type, this is an integer data type. So I'm just going to give RDD4 equals to RDD3 dot map, because we have to do it for every item. So lambda x colon x of 0. If I say x of 0 means x of 0 is going to get this value. X of 0 is going to get this value. Okay, so I'm just going to present RDD4. 0, 1, 2, 3, 4, 5, 6, 7. Total 7 are there. Let's execute it. You can see In all the places it is giving employee number. Select employee number. Okay. And do one thing. Instead of this, let me keep already 3 itself here. Because I'm just talking about select all columns here for all columns. Let me take this entire thing, copy. What is the task number? Task 10, 11, 12, 13, 14. So I wanted to get only a few columns, something like employee number, employee name, job, hire date, salary, department number, something like this. So we are able to see the same thing. I wanted to do it there also. Okay, so select required columns. So if you wanted to display required columns, then how you can do it? The same time, I'm just reading it, splitting the data, and taking out the header from here. Because when you apply the filter, that should the already should not have the column names. Okay, so up to here that we have seen just now, and I wanted to take only required columns here. RD4 equals to RD3 dot map lambda x colon x of 0. Then it is going to give the employee number. RD4 dot collect. So it is showing employee number, and I wanted to say comma x of 1. Now it is going to show employee name, but it will not show is because if it is a single value, can do it. If you have more than one value, then you have to keep them inside the tuple. Inside the tuple, you have to keep it. Now if you execute it, it will show. Employee name is coming, and x of employee name, employee name, job is there. Next person is job. Let's say it is a 2. I'm just taking this reference to apply the numbers. Employee number, name, job is required, date is required. So this is taking out. So 3, 4, 4 is required. X of 4. Our data also is coming. And then salary is required, that is X of 5 and X of 6. Sorry, X of 7. Let's execute it. Now can say department number, employee number, employee name, job, hire date, salary, and department number. Let's take out this. So only required columns as per this select statement. I'm just taking it. So I wanted to convert these data types. To convert these data types, we know already how we can convert it by using the int function. Okay, so I'm just going to say int open a brace. And if I re-execute this, then you can see for employee number, you cannot see the single quotes. And for salary, I'm just going to make this as a float. Here is the salary. Float, open a brace, and close a brace here. Let's execute it and show. Sorry, float, spelling mistake. Now cancel. And department number also, I'm just going to make this as an integer. Let's re-execute it. Now you can see. Okay, so this is perfectly all right. It is taking required columns. Okay, I'm just writing a comment here. Taking required columns. Okay, now the same thing. I wanted to apply a filter where department number equals to 10. Where department number equals to 10. Let's execute it. You can see 3 records here. The same thing how you can do it here. Let's take a copy of this. Task 15. Apply filter to display or to get employees who are working in department 10. So up to here same to same. So again we can use the filter function here. RD5 equals to RD4 dot filter lambda x colon. So here we need to provide the condition. So condition is on the department number. Now the output is coming like this. This is a 0, 1, 2, 3, 4, 5. So x of 5 equals to x of 5 equals to 10. X of 5 equals to 10. And if I say already 5 dot collect, it is going to give the data for only department number 10. So this is how we have seen how we can frame the condition. If you remember, we have come across x colon x modulus 2 equals to 0 to get the even numbers. And to get the odd numbers, we have taken 1. The same to same, I'm just doing here also. The same to same, I'm just doing in this particular place as well. Okay, so only department number 10 data it is getting. So don't think about the column names. We'll see how we can get the column names later. Okay. So this is how we can get the data for department number 10. For number of department number 10 and department number 20, both departments are required to bring it. As well as department number 20. So if it is a SQL server, we can use logical R operator or department number equals to 20. So some number of records you're getting. The same thing I wanted to do here also. Say 16. So we need to add one more condition. This is one condition. This is another condition. Okay, so we cannot use something like and. I guess it will not work. Let's try. It's an empty. Not and, sorry. R. Yeah, R is working. So in a data frame, we don't have a R like this. Okay, so how many records are 1, 2, 3, 4, 5, 6, 7, 8. Total 8 records. It's matching. Okay, so this is one condition and this is another condition. So when you use logical AND, it is not going to get the data, right? So because one employee cannot work in 2 departments. So this is simple how we can get the data for 2 departments. I wanted to say department number 10. Okay, let me take this. Apply filter to get employee details who are working in department number 10 and their salary should be. Let me take only after department number 10. Okay, so salary should be less than 2000. Okay, so I'm just writing something like this, salary less than 2000. The same thing, I wanted to do it here. So we can say and the salary is there in the fourth position, right? So I'm just going to say 4 here, less than 2000. Now let's see how exactly it is going to get. In the department number 10, if salary is less than 2000, then those details only I wanted to do it. So logical and also we can use it. And I wanted to check based on the text numbers we have seen. Now I wanted to get the employees who are working as managers. If it is going to work as a manager, then I wanted to get it. So manager is there in the which position 0, 1, 2. In the second position we have it. So I'm just taking out this x of 2 equals to manager. Now if I show here, it is going to show the data for only managers. So 3 records are there. You can cross verify that here. Job equals to manager. Now you can see 3 records here also. Okay, you're able to follow with me. Let me unmute yourself. If you have any question, you can ask me. Yes, any doubt here? Everyone is following with me, right? Okay, I hope you are following with me. Okay, that is fine. The next one is I'm just trying to give the various options when you go here. With the date, I wanted to apply the filter. After the dates I'm having. Where year of hire date equals to 2023 I'm taking. So, okay, so I wanted to get this data. I wanted to apply the filter. Okay, so apply filter to get employees who are hired in the year of 2023. Okay, so that I wanted to do it. So in order to do this, how you can apply the filter? Okay, so various options we can do. After taking the columns, you're applying the filter, but I wanted to do filter before this. Because this is fine, employee number is fine. So here itself, I wanted to take out the filter. I wanted to apply the filter. noted by Anastasia class. It is little tricky when you go for this. The date is there. I don't want to disturb it. Let me use here itself. Okay, so here what you have to do is you have to concentrate on which column you have to apply the filter. I wanted to apply the filter with this column, right? So 0, 1, 2, 3. RD5 equals to RD4 dot filter. Instead of going with the filter, I wanted to split the data. Okay, I wanted to split the data. Let's say lambda x colon x dot split. So here I'm going to take a hyphen. The data is there, right? Hyphen is there. RD5 dot collect, you can see. Split. What is happening? Okay. Let's do one thing. Otherwise, here itself we can do it. RD4 equals to RD3 dot map lambda x colon x dot split again. So I wanted to split the data based on okay. Here also can do it. The date is there here. 0, 1, 2, 3. So only 3 only I need to split it. So we can take x of 0 dot split. Let's try. If it is working, then we can do it here itself. So, sorry, x of 3. Yeah, we're able to get it. So that means you have to take this x of 0, comma, x of 1, comma, x of 2. As it is, you have to take it. X of 4 only, we need to split it. X of 3. I'm taking x of 3 as well, comma. And then let's try again, execute. So let me keep this entire thing in the tuple. Let's execute it. Now this is fine. Okay, so x of 3 is splitting into this place. And I need to take only this x of 0. Okay, so here itself I'm just going to take this. I don't need to go for another line to do it. X of 3, x of 4, x of 4 is what? Okay, let me check. 0, 1, 2, 3, 4, 5. 4 is, let me take x of 4 also here. X of 4, comma, x of 5. Let's execute it. I'm just splitting only x of 3. Okay, so this part. So in this one, the first part is 0. You have to take only 0 here. I'm just going to say a 0. If I take a 0, then here only is going to get. Now I can say here only is getting. This entire thing you have to convert into integer array. So I'm just going to say int of if we execute again, we can get the year also, right? Here is getting. The next statement, I'm going to apply the filter. Here itself, I can apply filter. Okay, let me do it here. Already 6 equals to already 5 dot filter lambda x colon x dot, sorry, x of in which position it is there. I can say -1, x of -1 equals to 2023. Let's take the data from already 6. You can see 1, 2, 3, 4, 5, 6. Total 6 records. So 6 records we are getting. Okay, so if you wanted to take out this column, you can take out this particular column. Okay, so let's say if I wanted to apply the filter on top of this directly, how you can apply this filter on already 3. Because I'm just making this comment for just understanding purpose. I took all these steps. You can directly apply the filter on top of already 4 dot collect. Here itself I can apply the filter. Let me say already 5 equals to already 4 dot filter lambda x colon. So here I need to take x of 3. X of 3 dot split. So split is based on the hyphen. And I wanted to take only the first value. This entire thing should be converted into integer. Equals to 2023. Close this. And if you see already 5 dot collect, you can see the same data. So just for understanding, I'm just showing how exactly we can take that into pieces. But basically, if you have an idea how we can do split, you can directly apply it. Okay. So this is how we can apply the filters if you wanted to filter the data. Okay. So in tomorrow's session, I'm going to take you through how we can aggregate the data. Like I wanted to show department-wise total salary. Sum of salary group by department number. So this results how you can get it, we are going to say in the next session. I'm stopping here. If you have any question, you can ask. Any question, guys? So definitely it will be a little tough, guys. You have to do practice again and again, then only can get it. You need to understand the positions, how exactly the positions is coming. Okay, so I am doing one real-time exercise here. I'll give this task, how you people can do it. We'll check. But you need to wait for some time to explain that particular task. Okay, I'm stopping here. We'll see you tomorrow. Thank you for joining.